So for problem number 1, we're asked to figure out whether this matrix is in echelon form, reduced echelon form, or neither. So we have to define a few things. What does echelon form mean? Well, to be in echelon form, a matrix has to have 3 things. 1, all non-zero rows are above rows of all zeros. All zeros. So if we had some row that was like this row would have to be below all the non-zero rows. This is a non-zero row because it doesn't have all zeros. So basically, we don't have to worry about that in this problem because none of these rows have all zeros in them. The other qualification for echelon form is that each leading entry must form a diagonal from left to right, top to bottom. Left to right, top to bottom. And lastly, every entry in the column below the leading entry must be 0. So that's what echelon form means, and I will go over that in a second. Now let me explain reduced echelon form. So reduced echelon form. Reduced echelon form has 3 qualifications as well. The first qualification is obvious. It has to be in echelon form. So it has to follow these 3 rules. Echelon form. 2, the leading entries are all 1s. And 3, each leading 1, since the leading entries are 1s, each leading 1 has zeros above it and below it. So notice how in echelon form, we only had zeros below, and in reduced echelon form, we have zeros above and below. So in order to be in echelon form, we need to follow these 3 rules. And in order to be in reduced echelon form, we need to follow these 3 rules. We can say that this matrix right here is in reduced echelon form. And it's also, because it's in reduced echelon form, it must also be in echelon form. But this is the more specific case, so we're going to go with that as the answer. Now let's examine why this matrix is in reduced echelon form. Let's look at this. This is the first leading entry. And if we want to know what a leading entry is, I can write the definition here. A leading entry is the leftmost non-zero entry in a row. Now let's check to see if this matrix is in echelon form. Now, this number 1 wasn't a problem because we don't have any row of all zeros, so we can already check that off. Now, let's check all the leading entries. So this is a leading entry. This is also a leading entry because it's the leftmost non-zero entry, so we skip this 0 and go to this 1. And then this is the leftmost non-zero entry. So these are all the leading entries. Do we form a diagonal from left to right, top to bottom? Yep. So these leading entries do follow echelon form. And are there entries in the column below it that are all 0? Let's check. This leading entry has zeros below it. That's right. This leading entry has zeros below it. And this leading entry, well, it has nothing below it, but it still counts. So this is in echelon form. Now that we know it's in echelon form, let's check to see if it's reduced echelon form. We know that it follows the first qualification for reduced echelon form because of the fact that a reduced echelon form matrix already has to be in echelon form, and we already figured out that it was. Are all the leading entries 1? They are. How about the zeros above and below it? Well, we already checked the zeros below it. Let's check the zeros above. There are zeros above this leading entry, and above this leading entry, there are zeros above it as well. So that's why this matrix is in reduced echelon form. Now we can follow the rules for reduced echelon and echelon. Now let's remember, the first rule for echelon form is that we have to check for any rows of all zeros. So that's not the case in this matrix. So rule 1 for echelon form checks out. How about rule 2? Rule 2 for echelon form says that each leading entry, so let's find out the leading entries. This is the leading entry because the leftmost non-zero entry. This is the leading entry, and this is a leading entry. Each leading entry must form a diagonal from top to bottom, left to right. Does that happen here? Yes. So the second rule for echelon form checks out. How about rule 3 for echelon form? Rule 3 for echelon form says that every entry below these leading entries, the ones in the blue circles, must be 0. These are 0, this is a 0, and this has nothing below it, so this doesn't really count. So it is in echelon form because it follows all 3 rules. Now let's check to see if it's in reduced echelon form. Let me write out the rules for reduced echelon form one more time. If it's in reduced echelon form, it has to be in echelon form, which it is. Leading entries are 1. Leading entries are 1, and the 1s have zeros in the columns above and below it. Above and below. Let's check the leading entries. This has a 0 below it, this has a 0 below it. This has a 0 above it, this has a 0 below it. And this has a 0 above it and another 0 above it. So it follows all the rules for reduced echelon form. Thus, we can say that this matrix is another reduced echelon form matrix. Now, let's figure out if this is an echelon form, reduced echelon form, or neither. So the first rule for echelon form is that we have to check for any rows of all zeros. This row does have all zeros. Now what did we say about rows of all zeros? We said that they have to be the bottom row. All the other rows have to be above it. Is it the bottom row? No. So we can say that this matrix is in neither echelon nor reduced echelon form. That's it for that matrix. Okay, now the first thing we want to do is to check for rows of all zeros. So the first thing we want to do is check for rows of all zeros. Do we have any? Well, this row doesn't have all zeros, this row doesn't, this row doesn't, and this row doesn't. So we've bypassed that first step. We don't have to worry about that step. 2, let's check the leading entries. Check the leading entries. So, the leading entries are the leftmost non-zero entries. So, in this row, this is the leftmost non-zero entry. In this row, the leftmost non-zero entry is the 2. In this row, the leftmost non-zero entry is this 3. And in this row, the leftmost non-zero entry is the 4. So these are our leading entries. And check if the leading entries form a diagonal. Check if leading entries form diagonal. In this case, do they form a diagonal from left to right, top to bottom? They do, so this checks out. Now the fourth thing we want to do is check for zeros below the leading entries. Now, we've already circled the leading entries, so all we have to do is check for zeros below them. This leading entry does have all zeros below it. This leading entry has all zeros below it. This leading entry has all zeros below it. And this leading entry can't have any zeros below it, so we don't count it. So, we've checked the fourth step. So now, after this, we can determine that the matrix is in echelon form, at least. It could be reduced echelon form, so we might want to check some extra steps. 5. Well, now that we know that it's in echelon form, we can check, okay, well, now that it's in echelon form, is it reduced echelon form? What we do is check the leading entries again. Are they ones or are they not ones? Check leading entries. Are they 1? Now let's check these leading entries. This leading entry is a 1, but this leading entry right here is a 2, and the other leading entries are not 1s. So this matrix is not in reduced echelon form. It's just in echelon form. So this matrix is simply in echelon form. Okay, so what's the first thing that we want to do with this matrix? The first thing we want to do is check for rows of all zeros. Check for rows of all 0. This row is a row of all 0, and it's the bottom row, so that checks out. 2. Check leading entries. So what we're going to do is circle all our leading entries. Remember that leading entries are the leftmost non-zero element in a row. So in this row, this is the leftmost non-zero entry, and this row has the bottom row has no leading entries because all of them are 0. So the third thing that we want to do is check for a diagonal from left to right, top to bottom. Are these going from left to right, top to bottom? Are these leading entries going in that direction? They are. So we can say that the diagonal has been checked. And lastly, for echelon form, the last thing we want to check is, so for echelon form, the last thing we want to check is, are all The fourth thing we want to check for echelon form is for zeros. Check for zeros. Are there zeros below this row? Are there zeros below this leading entry? Yes. Are there zeros below this leading entry? Yes. So we can say that this matrix is in at least echelon form, but we cannot say for sure because we want to check if it's in reduced echelon form. So let's check if it's in reduced echelon form. We need to do 2 additional steps to check if it's in reduced echelon form. We have to check, are the leading entries 1? Are the leading entries 1? They are. These are the only 2 leading entries and they're both 1. So that checks out. The last thing we want to check for echelon form is, are there zeros above and below the ones? Now let's check. Are there zeros above and below the ones? Well, below this one right here, there's a 0 here, and there's a 0 here, so yes. And for this one, there's a 0 here, and a 0 here, so yes, there are zeros above and below the ones. Thus, we can say that this matrix is in reduced echelon form. Now let's check this matrix to see whether it's in echelon form, reduced echelon form, or neither. Now, I'm not going to write out the steps this time, I'll just say them out loud. The first thing we want to do is check for any rows of all zeros. We don't have that, so we can move on to the next step. The next step is to find all the leading entries. So, the leading entries are the leftmost non-zero elements in a row. So the leftmost non-zero element in a row. The leftmost non-zero element in a row, these are called your leading entries. Now let's check, are they going in a diagonal from left to right, top to bottom? They are. And do they have zeros below them? So they have, this one has a 0 and another 0 below it, this one has another 0 below it, this has nothing below it, so it doesn't count. So we can say that because there are zeros below it, below all the leading entries that form a diagonal from top to bottom, left to right, that this matrix is in at least echelon form, but we have to check, is it in reduced echelon form? The way we check this are looking at 2 different things. Are all the leading entries 1? Well, actually, they are. This leading entry is a 1, this leading entry is a 1, and this leading entry is a 1. Now, since we know that the leading entries are 1, we have to still check one more step. Do all the leading entries have zeros above and below it? Well, this leading entry does. It has a 0 below it and another 0 below it. This leading entry right here has a 0 below it, but wait, it has a 1 above it. So that means that it's not in reduced echelon form and it's only in echelon form. Now, first thing we do is to check for rows of all zeros. That isn't the case in this matrix, so we can move on to the next step. The next step is to figure out all the leading entries. The leading entries are the leftmost non-zero entries in a row. So in this row, the leftmost non-zero entry is this one. In this row, it's this one. In this row, it's this one. In this row, this is a leading entry. Now we have to check, are these leading entries going in a diagonal from top to bottom, left to right? Now it is going from top to bottom, but it isn't going left to right because of these 2 right here. So we can say that this is in neither reduced nor echelon form. Neither reduced echelon nor echelon form. The first thing we want to do is to figure out whether there are any rows of all zeros. We actually do have a row of all zeros. It's this row. And it's at the bottom, so we know that it does not disqualify it from being an echelon form. The second thing we want to do is we want to check all the leading entries. So I do that by circling them. They are the leftmost non-zero element in a row. Notice how this entry is 0, so I have to go to the next one. This entry is 0, so I skip it. This entry is 0, so I skip it. So I go to this one. What I was doing before was I was going to the left and stopping when there's a 0 below it, 0 before it. However, I can just skip all the zeros in the row. That's just another way of doing it. Now, I have to skip this 0, skip this 0, skip this 0, until I get to the leftmost non-zero entry. And this row is all zeros, so it doesn't have any leading entries. Now let's check to see if there are Now let's check to see if the leading entries form a diagonal from left to right, top to bottom. They do, so that checks out. Let's check to see if there are zeros below each leading entry. Below this leading entry, there are all zeros. Below this leading entry, there are all zeros, and below this leading entry, there are all zeros. So this is in echelon form at the very least. Now let's check to see if it's in reduced echelon form. If it's in reduced echelon form, all the leading entries have to be 1. This leading entry is 1, but this leading entry is not 1, so it's not in reduced echelon form. It's only in echelon form.